Let's get started with number one. And in number one, we have the situation where we have the variable on both sides. So I have the variable here, I have the variable here, and I want the variable on just one side of the equation so that way I can isolate it on that side of the equation. So I get to choose which side I want to keep it on, and as I told you before, my preference is to eliminate the variable with a smaller coefficient. 4x, 2x, coefficient of 4, coefficient of 2. 2 is smaller, so my choice is to get rid of this one and keep my variables on the left side in this case. But once again, you can always choose to keep the variables on this side and eliminate that one, so you do have that choice. To get rid of a 2x, I take away 2x from that side, and of course I got to do it from the other side as well. And 2x minus 2x, that's gone. You can cancel it out to 0. And over here, 4x minus 2x is just a positive 2x. The 16 comes down. And all of this is just 0 now, so I don't have to write anything else there. Now it's just a two-step equation where I'm trying to isolate now my only variable, which is only on one side now, which is perfect. So again, I'm not going to spend a ton of time here. I'm going to get rid of this first. It's a plus 16. I'm going to do minus 16 on both sides. So that does eliminate the two 16s right there, and hopefully you can see that. It's kind of like a light orange. And on the right side, 0 minus 16 is a minus 16. And then, of course, to get rid of this multiplied by 2, I divide both sides by 2. And here we have simplifying to 1, which means x, or 1x, doesn't matter how you look at it, is negative 16 divided by 2, which is a negative 8. And that is the answer for 1. Again, you can always check your work by taking this negative 8 and plugging it in for both x's here, and it will work out, or at least hopefully it'll work out. If it doesn't, then something went wrong. Moving on to number 2. Again, same deal. We have a variable on both sides of the equation, and I want it on just one side. So I'm going to get rid of one of them. Again, I choose the variable to get rid of which has the smallest coefficient. 8 in front of this variable, 5 in front of this one. The 5 is smaller. I get rid of that one. You can get rid of this one if you want. It's a personal choice, the way I'm used to solving these problems. I think it's a slightly better choice, but that's me. So once again, 5x minus 5x, and the reason I did backtracking, I subtracted 5x from both sides because it's the opposite of 5x. 5x minus 5x, that's 0, gone. And of course I have to do it from both sides. So that's gone, or it's now a 0. And on the left side, I'm left with 8x minus 5x, which is 3x minus 3. On the right side, I have 15 and nothing else because this is 0. So 15 plus 0, or just 15. Alright, that being said, now I just have a two-step equation. Again, these should be pretty easy for you by now. Get rid of this minus 3 first, it's further away, by doing plus 3 to both sides. Of course, right over here, minus 3 plus 3, that's a 0, so it's gone. I'm left with 3x equals to 18. And then I gotta get rid of this multiplied by 3, which I do divide by 3 on both sides to keep it balanced. And again, here it simplifies down to 1. And you can probably barely see that orange. It's not a very good orange. Not a very good orange at all. And I'm left with x equals to 18 divided by 3, which is 6, which is my final answer. Alright, questions about 1 or 2? Kind of rushing through these, I shouldn't be. All right, moving on to number seven. So number 3 is just like the other problem types here. I have the m variable on both sides. I got to get rid of it on one side, and as always, my personal choice is to get rid of the one with the smaller coefficient. 7, 3, 3 smaller. How do I get rid of a 3m? What can I do? Subtract 3m from both sides. On the right side, that's now a 0, it's gone. On the left side, 7m take away 3m is 4m minus 11 equals to a negative 19 because that is now 0. Alright, now it's a two-step equation. And I'm going to go and get rid of this minus 11 because it's further away first by doing plus 11 to both sides. Over here, minus 11 plus 11 is gone. Over here, I get 4m equals 2, and on the right side, negative 19 plus 11 should be 8, positive 8. I'm sorry, negative 8. Wow, negative 8. Because the negative here is a bigger number. And then I'm going to get rid of this multiplied by 4 by dividing by 4 on both sides. Multiply by 4, divide by 4 is the opposite. That simplifies down to 1. So 1 times m is m itself. There's just an m here. Negative 8 divided by 4 is a negative 2. Because different signs for division always yields a negative number. So that's number 3. Those are the first 3. So let me know if you have any questions on any of those before I move on. Alright, then we have number 4 coming up. Number 4 is again a pretty similar problem to the ones we've been doing. Not a whole lot that changes. So I'm going to get rid of one of the variable terms. I have them on both sides, the a term. I'm going to take one of them off. My choice, you guessed it, that one. And the reason I choose that one is because it has the smaller coefficient. 11, 4, 4 is smaller. How do I get rid of a 4a? I subtract 4a. And if this was a negative 4a, I would add 4a to both sides. But since this is a positive 4a, to get rid of a positive 4a, you got to subtract 4a from both sides. And of course, I got to do that from both sides of the equation. Here on the right side, that's gone. It's now a 0. On the left side, 11a minus 4a yields a 7a, positive 7a. Plus 9, the 9 comes down. And here I just have a 30, a positive 30. I'm not going to write the plus in front of it. Then it's a two-step equation. Get rid of the plus 9 first by doing minus 9 on both sides. 7a equals 2. That's 21. And then get rid of this times by 7 by doing the opposite, which is divide by 7 on both sides, of course. That simplifies down to 1. And a equals to 21. Nice and simple and clean. So let me know if you have any questions about any of the work or the answer for 4. Alright, moving on to number 5. The only difference with 5 as opposed to the previous 4 problems is that I have that parenthesis here which I need to break down. There's nothing I can do inside the parenthesis. X plus 3, that's x plus 3. So the next step is to break down that parenthesis by multiplying everything inside by whatever is immediately outside. So I'm going to distribute this 2 to both members inside, which gets me 15 minus x, nothing changes on this side yet, equals to 2 times x plus 2 times 3. So I'm going to rewrite this again. I'm going to take it one step at a time. 2 times x is 2x. And 2 times 3 is 6. Now it looks just like the previous 4 problems. I have variables on both sides, and I'm going to get rid of one of them. The coefficient in front of this one is 2. The coefficient in front of this one, it's invisible. You don't see it, but it's 1. So technically this one's smaller. I want to get rid of this one. You could always get rid of this one too if you wanted to. How do I get rid of a minus x? What's the opposite of minus x or negative x? Plus x. Just plus 1x or just plus x. And of course I got to do it to both sides. So minus x, the opposite is plus x. Kind of like minus 1, what's the opposite of minus 1? Plus 1. So minus x plus x, that's gone. It's now 0. So I'm left with just 15 here. This minus sign is gone. It belonged to the x, which I now turn to 0. 2x plus x, and then the plus 6. Now it's a two-step equation, and I'm going to get rid of this plus 6 first by doing minus 6 on both sides. Gone. And that leaves me with 3x equals to 15 minus 6, that's a 9. And then of course my last step, get rid of this multiplied by 3 by doing the opposite, which is what? Divide by 3 on both sides. Simplifies to 1. And 9 divided by 3 is just 3 equals 2x. And that's my answer for number 5. Let me know if you have any questions. Alright, moving on to number 6 then. Number 6 is actually very much like number 1 through 4, which is bigger numbers, so it's actually a little easier in some ways than number 5. Again, I have variable terms on both sides, and I want them on one side only. So I'm going to get rid of one of the variable terms. And I always choose the one with a smaller coefficient, 26, 19. 19 is smaller. How do I get rid of a positive 19c, or just a 19c? Subtract 19c from both sides. Subtract 19c here to get rid of it from the other side because I have to keep the equation balanced. Oops. So this simplifies down to just 0. I have 31, or a positive 31, left on the left side. 26c minus 9c, minus 19c is 7c, minus 74, okay. Now it's a two-step equation, and I will get rid of the minus 74 first, because it's further away, by doing the opposite. And again, the only thing different here is just bigger numbers, so slightly more difficult arithmetic calculations. Not a big deal. Minus 74 plus 74 cancels to 0 just like anything else with two opposite numbers. And on the left side, 31 plus 74, anyone know the answer to that off the top of their head? Some quick mental math. 105, if memory serves. Yes, that's right. And then my last step is to divide both sides by 7 to get rid of this multiplied by 7. And does anyone know what's 105 divided by 7? If you said 15, you're correct. And that is the answer to number 6. Solves just like any other problem we've done in this section, except with slightly bigger numbers. Alright, moving down to 7. And the only twist to 7 is that we have some decimal numbers here. Not a big deal. Decimals. We solve it the same way. I have two w terms here and here. I want just one w term on one side of the equation. So I want to get rid of that one because it's got the smaller coefficient. 8, 5, and of course 5 is smaller. How do I get rid of a 5w? By doing minus 5w. And of course I have to do it from both sides. So that is now officially 0. I'm left with 9.9, a positive 9.9 equals to 4.8, and 8w minus 5w is a positive 3w. Then of course I'm going to get rid of this right here by doing minus 4.8 from both sides, the positive 4.8. To get rid of it, I do a negative 4.8. Okay. On this side it's a 0. And on this side we do end up with a positive 5.1. If my math is correct, of course. Seems right. 9, that's 1. Yep, that's right. Alright, and my very last step, of course, is to divide both sides by 3. And does anyone know what's 5.1 divided by 3? If you don't, what's 51 divided by 3? It's 27. So 5.1 divided by, 17. And 5.1 divided by 3 is 1.7. So that is the answer to 7. It's 1.7. Any questions on number 7? I may throw in a decimal problem in there on the quiz. Shouldn't worry you. You solve it just like anything else, except you got to deal with some decimals there. Shouldn't be scary by now, I hope. If they are, I'm sorry. Alright, moving on to number 8. We're almost done here. 3 more to go. Alright, number 8, we have a problem that's very similar to number 5, so this shouldn't be too bad at all. The first thing I'm going to do is I want to break up this parenthesis because there's nothing that I can do inside, which gets me 2 times 3x plus 2 times 11 equals to 6x plus 4. Alright. It's not bad at all. 2 times 3x is 6x plus 2 times 11 is 22 equals to 6x plus 4. Alright, now I gotta get rid of one of the variable terms, except they're both the same. They're both coefficient of 6. Which one do I get rid of? Doesn't really matter, because if I get rid of one, I'll get rid of the other one. So I'm going to choose the one on this side for no particular reason. How do I get rid of a 6x? By doing minus 6x, and of course I do it to both sides. So both of them cross out to a 0. Okay, that's kind of neat and convenient, you say. Which gives me 0 plus 22 equals to 0 plus 4, which is 22 equals to 4. And we all know that 22 does not equal to 4. That just, no. 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 Solution. Well, that's your answer for number 8. No solution. Cannot be done. Makes no sense. Yep. And if you get a problem like that on the quiz where you end up with a number equals to a number and the two numbers on either side of the equal sign are not the same, that can't possibly be. So no solution. That's what you write. Any questions? Alright, moving on to our second to last problem. I threw in a fraction in here just for fun, because, you know, love fun. And we deal with this fraction problem just like we've dealt with all of the other fraction problems before. I convert them into non-fractions. So for that, I need to find your key to tell me what? Of course, the LCD, the least common denominator. And what is the LCD in this case? What is the least common denominator? I have a 3 here, I have a 2. The constants are whole numbers, but you can pretend that they're over 1. So the 11 is over 1, the 3 is over 1. So I have 3, 1, 2, 1. What's the number that they all go into evenly? I'm hoping you're thinking of 6. Because 3 goes into 6, 2 goes into 6, and of course 1 goes into 6 as well. So I want to multiply both sides by 6. Alrighty then. And then I want to distribute that 6 to everything inside. It gives me 6 times h over 3 plus 6 times 11. All of this equals to 6 times h over 2. And of course, minus 3 times 6. There we go. Took a little longer than I thought. At any rate, so I can do some canceling out, which I like to do, as you can probably tell. 6 and a 3, I'm not going to do the whole, well, I am going to do the whole breaking down thing, because I like to break things down. So 6 is 3 times 2. So so this 6 is now gone. I can cancel out a 3 and a 3 here. Okay, because I can write 6 as 3 times 2. Over here, I can break this 6 down into, again, 3 times 2. And so the 6 is gone. So I can cancel out a 2 and a 2. I have a 3 left here, I have a 2 left here. These 6's are still intact. Okay, so I can do 2 times h, which is 2h, plus 6 times 11, which is 66, equals to 3 times h and minus 3 times 6, which is 18. So let's stop here for a second, and if you have any questions about how I did all that, ask me now, and I'm also going to check my math as we do that. All right, I don't see any mistakes, but doesn't mean I didn't make any. So let's just go with it. All right, now I have an equation with a variable on each side. So I got to get rid of one and leave the other one alone. And as always, I choose the one that has a smaller coefficient. In this case, the 2 is smaller than the 3. So I'm going to get rid of it. And of course, I do it to both sides. To get rid of a 2h, I do a minus 2h. That's now 0. And on the left side, I'm just left with a positive 66, or just a 66. 3h minus 2h is just an h, or 1h, if you want to write that 1 in front of there, minus 18. And now this is a very simple one-step equation. Plus 18 to both sides. That's gone. And doesn't anyone know what 66 plus 18 is? $84, unless my math is wrong, equals to h. And I think that's right. Yep. All right, that was number 9. Any questions? We have one more problem to go. We are on track. And this is the word problem. This one, the challenge came from setting it up. Once it's set up, it's actually pretty easy to solve. But setting this one up is probably the most difficult thing you can do. So far in this section, at least. So I have an apple has about 30 calories more than an orange. Okay. 5 oranges have about as many calories as 3 apples. How many calories in each? Well, I don't know how many calories an apple or an orange has, so I got to give them variables. But I don't want to give them different variables because we haven't done that yet. We haven't done equations that have 2 different variables in them. So I want to choose one variable, and I'm going to assign it to the orange. I'm going to say that the orange, and because it's an orange, I'm going to circle it with an orange, yay, is going to be my x. Okay then. And I know that an apple has 30 calories more than an orange. So can I say that an apple, and I'm going to circle the apple with a red, if I can find a red. Because, I don't know, red is the apple color. So if orange is X and an apple has 30 more calories than an orange, can I say that an apple is, I'm going to let you tell me what that is. Hopefully someone said X plus 30. So if orange is X, an apple is 30 more calories than an orange, so X plus 30 would be the apple. Alright, good so far. Now let's set up the rest of the equation. 5 oranges have about as many calories, so 5 oranges. I know an orange is X, so what would 5 oranges look like? If 1 orange is X, 5 oranges are 5X. Have about as many, that tells me there's the equal sign, as many calories as 3 apples. And I know an apple is X plus 30, so what would 3 apples look like? 3 times X plus 30. So 5 oranges, 5X, 3 apples, 3 times X plus 30. Now that it's in this form, this is cake. This is not as difficult as many of the problems we did prior to this. I want to go ahead and break down, first of all, any questions on how I got here? You probably have some questions. Okay, I'm going to break down the parenthesis. And I'm not going to spend too much time doing that. 3 times X is 3X. 3 times 30 is 90. Now I have to choose one side to keep my variable on because now it's on both sides and I don't like that. I always choose to get rid of the one that has a smaller coefficient, and in this case it's the 3x. So I'm going to take away 3x from both sides. So that's gone. I'm left with 2x equals to 90. And my last step is to divide both sides by 2 to get rid of this times 2. And I can safely say that my x is 45. Now this isn't the full problem. What am I missing to give me the full answer? So x is the oranges. So I can say that an orange has 45 calories. And I'm going to just say cal for calories. How many calories does an apple have? $30 more calories than an orange. So 45 plus 30 gives me 75 calories. So you can say in a sentence, and I don't have room for that, but the way you would answer this, you would say, an orange has 45 calories and an apple has 75 calories. And that's how you would end this particular word problem. Alright, if you have any questions, let me know. There may be a word problem on the quiz. If there is one, it's more than likely going to be extra credit, but you know, but still something you should shoot for. Alright, thank you very much.